Let's let's try this. Click on a launch app of dynamic daylighting, and you will see a default model of a room. And on the panel, let's start over by removing all windows and click OK. And this room represents the uh, room covered by 6 surfaces. If you look into here, there is a ceiling that is not being shown, but it's there. Let's say you want to test a single room inside your building, which has the window that is size about this dimension. You can also move the wall freely to recreate the space that's in your design. And I would maintain the seal of the window above the working plane to prevent some error that I noticed in this software. And I would like to design a window that is higher up. You can also control the geometry of your design by scrolling this here. And the room height. You can control the mullion depths and frame depths, and number of dividers can be controlled. And you can also control the transmittance of the glazing and also the ground albedo, which is important for your consideration for light that's hitting the ground and coming in. Working plane height, I would keep this as a 750 millimeter, and I will leave everything else as a default. Right now, we are measuring in a real-time daylight factor for this given point in time. First, let's click the climate-based analysis and click the daylight autonomy. Set the threshold as 300 lux. Since this is the climate-based analysis, we need to set the climate data first. You can bring your own weather data. I will click the New York for here. Now the weather data is incorporated. You can check if it is the right data on your climate selection. And we can now start calculating the daylight autonomy. Click calculate, and it will give me the result such as this. I can control the view to be plan, and now I see the overall distribution, and I can read what it means by looking at the legend here. And I can also change the display view, and I want to keep the color, and I want each point's reading of the daylight autonomy. And I see at this point 77% of time at this point is over the threshold that we set. This is the daylight autonomy, and we want to uh, get a spatial daylight autonomy, which represents a single number of how well this room is performing as a daylighting receiver. So in order to do that, the concept is to block out the area where uh, more than 50% of time is falling to this threshold that we created. Therefore, we can go to the setting and design target, which set at a 50%, which is what we want by the definition of the spatial daylight autonomy. And it's already giving me the single number that I want. And I can also, by clicking this, it visually gives me the area that I consider it to be fully daylit based on a definition of spatial daylight autonomy. And I can go to plan and eliminate these numbers and this grid and document it. And let's try the useful daylight illuminance, which is UDI. Click UDI. As I described, it not only gives lower threshold, which we should set at 300 lux, and upper threshold, which we set at 3000 lux. And we can click calculate again. Since this is south facing wall, I can notice that a lot of areas that was previously considered to be a daylight zone based on the definition of spatial daylight autonomy is no longer so. Let's look at the overall gradient and look at how much each of the points are. So we notice that at the premier zone, it is no longer above 50% in a lot of portion of the area. It is close, but not quite there. Therefore, we determine that the area at, that is closer to window is more likely to be overlit for the most of the time, and we need some device to control that overlit zone.